Welcome to today's video. It is Leetcode problem number 80. It is to remove duplicates from sorted array. So there is an easier version of this problem. This is slightly different and this has medium complexity. So given an integer array num sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. So we have given an integer array and we have to make sure that one element does not appear more than 2 times. And we have to return the number of valid elements in the array. It doesn't matter what is contained in the later portion of the array, which is after the valid position. But another catch here is that we have to do it in place. We cannot use another array. So let's look at an example to understand it better. So in the first example, there are 3 ones, 2 twos and 1 3. So one of the ones should be removed. And if you look at the output array, it has 1 1, 2 2, 3 and the output is 5. And if you see here, the last element can be, it is an underscore here, but it can be anything. So we don't have to worry about that. We just have to make sure that first 5 elements of the array are valid. So this is a problem statement, and now let's look at the thought process. Let's look at this example which was given as the first example in the problem statement. So we need 2 pointers. So the green pointer here denotes the position until which the array is valid. So if you think about it, the array is valid always for the first 2 positions, because even if the element is same, it is a valid scenario, or if the element is different, it is still a valid scenario. And the third pointer, the red pointer, is the iterator which will go through the elements. So we compare the elements at these 2 positions. If you see here, it is same. But if it is same, we have to check if this element is same as the one which was before the green pointer. So even that is same, which means that this current element is a third element. So this is not a this is not a valid scenario. So we have to make sure that this is not this is moved to the end, or this is removed. So what we do is we increment the pointer. So we reach here and we compare. Is this element same as the element at the valid position? No. So this is a good element. So we have to increment, we have to move it to the place position which is after the green pointer. So we move it here and we move this pointer here, because now the array is valid until this point, and this pointer has to be moved here because we already looked at this element, the element which is in this position. So this element is already handled, so we don't have to worry about that element anymore, and our array is valid until this green pointer. Now when we compare the current elements, which are 2 and 2, they are same. But is the element, is this 2 which is present at the red pointer location same as the one which is present before the green pointer? No. So this is a valid element. The element which is at the red pointer is a valid element. We just have to move it to the next available position, which is this one. So let's do that. So we move this to here. So if you see here, since the numbers are same, it doesn't make a difference. I'm just doing it so that you understand. So once we do that, we know that the array is valid till the point, this point, and we have already considered this element, so we have to move it to, we have to increment the red pointer. So now when we look at this element, are both the same? No. So it is a valid element. So we have to move it to the next valid position, which is this one. So if you remember, the green pointer denotes the position until which the array is valid. So next valid element has to come after that. So that is what we do by moving it. So we take this 3 and put it here, and we move the pointer here, and this pointer will go out of the array. So this is our output array, and if you see here, the first 5 elements are valid. So this is the logic which we are going to code. Now let's code the solution. already written the class, and I've initialized variables, and let's see what those are. So one thing is that we are just handling the boundary condition here. If the array length is less than 3, which means that we can just return the array length, because array has just 2 elements, and it is going to be always a valid scenario, because even if those elements are same or different, it doesn't make a difference. Okay, so we are handling the boundary condition here. So then we have a variable to store the current element. We can even do without this element. I'm just adding this element so that our code is more readable. And then we have a pointer. This pointer is to iterate through the array, and this is valid until. So valid until pointer shows the position until which the array is valid. Okay, and this is a while loop. So we have to loop through while the pointer is less than the array length. So let's initialize this one to the current element. So next, a valid scenario, a good element. We come across a good element. So we have to write an if condition with 2 scenarios here. So if the current element is not equal to the element which is at this position, or if the elements are same but the current element is not equal to the element before the valid element, which means that this is only the second occurrence. So this is a valid element. Okay, so we have to just keep the element in a valid position, so which is nums. We have to increment the pointer by 1, and we have to increment the pointer because we already handled that element. So else invalid element. So there is a case that we reached the end of the array. So if that is the case, then we have to we can just break out of this. So if pointer equals then we can just break, else we have to iterate until we find an element which is different. Okay, so we can use a while loop. So while pointer is, so we cannot go out of the boundary, so pointer is less than nums length, and nums pointer equal to the current element, we have to increment the pointer. So what we are trying to do here is we are trying to find an element which is different from the current element. So we come out of this loop either when we find a different element or we reached at the end of the array. So if in case we found a good element, then we can put it in a valid position. So that is it. That's the code, and let's run this and see. We pasted the code to Leetcode. There were few small corrections. So one was that in this place I was assigning current value to valid until position, but we have to assign the value which is at the pointer, not the current value. So that was one thing. Second one is that we have to see if the pointer is less than nums length minus 1. So because the index of the array starts at 0, we have to, or the last index will be 1 less than the size of the array. So let's run this and see. So it has passed the test cases. Now let's submit. So it has passed all the test cases, and the runtime is 0 millisecond. It beats 100% of users with Java, and the memory is 44 MB, and it beats 81% of users with Java. Thank you for watching this video.